Hello everyone, and a warm welcome to the Webstack Academy team and faculty. My name is Omgare, and today I am excited to present my internship project titled Food Genie. Food Genie is a full-stack AI-powered ordering web application that I developed during my internship at Webstack Academy as a MERN Stack developer. The primary objective of this project was to maintain a modern food ordering platform while integrating the artificial intelligence into the overall user experience. Most existing food platforms mainly focus on displaying the restaurants and allowing users to place orders. I wanted to go one step further by making the platform intelligent. Instead of users spending time reading the long menus, scrolling through hundreds of reviews, or manually searching for the suitable dishes, Food Genie uses an AI to simplify the complete food ordering experience. The application includes four major AI features. The first feature is automatically generates professional restaurants quality descriptions for menu items. The second feature is it analyzes hundreds of customer reviews and provides a concise summary of the customer sentiments. The third feature, it recommends meal based on the natural language preferences such as the budget, the dietary restrictions, or the personal taste. Finally, the application allows users to search naturally using sentences like show me vegetarian food under 300 rupees with good ratings instead of just manually applying multiple filters. Throughout this presentation, I'll be explaining the motivation behind the project, the technologies I used, the overall system architecture, each AI feature, the backend and the front-end implementation, the challenge I faced during the development, and finally, I will be demonstrating the complete working application. Before building any software solution, it's important to clearly understand the problem. When I started analyzing the existing food ordering applications, I noticed that although they provide thousands of restaurants and dishes, they still leave users with several frustrations. The problem is that the menus often contain only the name of the dishes without any meaningful description. For example, if someone has never eaten paneer lavabdar or maybe mushroom, they have absolutely no idea what the dish contains, how it tastes, or whether it suits their preference. This certainly often causes users either to spend extra time searching online or simply choose something they already know. The second major issue is related to the customer reviews. Popular restaurants can accumulate hundreds or thousands of reviews. While these reviews contain valuable information, restaurants owners rarely have enough time to read individual reviews manually. As a result, important customer feedback often remains hidden, making it difficult for restaurants to identify recurring strengths and weaknesses. And the third issue is the traditional food search. Most of the applications require users to manually apply filters such as cuisine, vegetarian option, price range, rating, and location. However, people naturally think in complete sentences rather than filters. For instance, a user simply wants to say, I want cheap vegetarian food near me. Instead, they are forced to select multiple filters one after another. This creates unnecessary friction in the ordering process. These three problems became the foundation of the Food Genie. So the objective is to use AI to make the food ordering simple, faster, and much more intuitive. To solve these problems, the Food Genie was designed around a simple but powerful idea. Instead of treating artificial intelligence as an additional feature, the placement of AI was at the center of the application. Every intelligent interaction first passes through an AI layer before reaching the database. The overall workflow is straightforward. Everything begins with the user's request or question. The user may ask a recommendation, request a menu description, search naturally, or analyze reviews. The request is first received by the Food Genie application. The application then sends the request to the AI engine, which is powered by the Groq large language model or LLM. The AI understands the user's intent, processes the request, and generates a structured information instead of plain text whenever necessary. Finally, the backend uses this structured information query, the MongoDB database, and generates meaningful responses. This architecture allows users to communicate naturally instead of learning how the application works internally. The AI essentially acts as an intelligent translator between the human language and the database logic. As a result, users experience faster searches, personalized recommendations, automatic menu generations, and summarize customer feedback without any additional efforts. Food Genie is entirely built using the MERN Stack, which provides a complete JavaScript-based development environment from front-end to back-end. Now let's briefly understand the role of each technology, starting with the MongoDB. The MongoDB is a NoSQL database used to store all the application data. This includes the user accounts, restaurant information, menus, orders, shopping carts, coupons, and other business-related data. Because MongoDB stores information in flexible document format, it becomes easy to manage the complex relationship without requiring a rigid table structures. Next is the Express.js. Express acts as a backend framework. It handles all the REST API routes, receives client requests, communicates with the controller, validates the incoming data, and returns responses back to the front end. Now the front end. It is built using the React along with Vite. React allows the user interface to be divided into reusable components, making the application easier to maintain and scale. Vite provides a much faster development environment with rapid hot modules, replacement, and optimized bullets. Finally, the backend, which is on Node.js server. Node.js serves as a runtime environment for the backend. Since both frontend and backend uses JavaScript, development becomes much more efficient because the same programming language is used throughout the entire project. This end-to-end JavaScript ecosystem was the one of the main reasons the MERN stack was selected for Food Genie. Now, let's take a closer look at the complete system architecture behind the Food Genie. The application follows a layered architecture where every layer has a specific responsibility. The process begins at the React frontend. This is where all the users react with the application through pages such as home, restaurants, menu, carts, orders, and the AF features. Whenever a user performs an action, the request is first passed through the Redux store. A Redux store manages the application's global state, ensuring that user information, shopping cart contents, authentication status, and other shared data remains synchronized all over all the components. From Redux, requests are sent to the backend using Axios. The Axios acts as an HTTP client responsive, responsible for the communication with the Express server. Inside the Express, the request reaches to the appropriate API routes. Each route forwards the request to its corresponding controller, where the business logic is executed. If database access is required, the controller reacts with the MongoDB using the Mongoose models. For AI-related features, the architecture includes a dedicated AI branch. Instead of directly queuing with the database, these requests are forwarded to the Groq large language model API. The AI processes natural language inputs and returns a structured JSON response. Those responses are then interpreted by the backend and either used to generate content or converted into MongoDB queries. Supporting this entire architecture are additional infrastructure services. JWT or JSON Web Tokens is used for secure authentication and authorization. Cookie-based sessions maintain secure user login. Cloudinary manages the image uploads efficiently, ensuring that the food images and the restaurant assets are stored outside the application server. This layer architecture keeps every component independent, modular, and scalable, making future maintenance and feature additions much easier. Now let's move on to the AI-powered feature of Food Genie, which is the AI dish description generator. One common problem faced by restaurant owners is creating attractive menu descriptions. Writing professional descriptions for every dish is time consuming, especially for restaurants with large menus. Many restaurants simply upload the dish, their names without any explanation, leaving customers unsure about what they are ordering. To solve this, the Food Genie has an AI-based menu description generator. The workflow begins when the restaurant owner enters only the name of the dish. For example, let's consider paneer tikka. This dish name is sent from frontend to the Express backend through an API request. The backend controller then creates a carefully designed prompt and sends it to the Groq large language module API. Instead of asking the AI to simply describe the dish, prompt engineering is used to guide the model towards producing structured and useful content. The prompt instructs the AI to generate a restaurant quality description along with cuisine information, ingredients, taste, profile, and allergen details. The AI processes the request and returns the generated content within a few seconds. Finally, the backend sends this information back to the frontend where it can either be displayed on to the restaurant owner for review, save it directly to the MongoDB database. This feature significantly reduces manual efforts while maintaining the consistency across all menu items. Instead of spending several minutes writing the description for every dish, restaurant owners can generate professional quality content almost instantly. The second AI power feature is the AI Review Analyzer. Restaurants often receive hundreds or thousands of customer reviews. Although these reviews contain valuable information, it is almost impossible for restaurant owners to manually read every single review and identify the common trends. To solve this problem, the Food Genie AI-based review analyzer system is built. The process begins by collecting multiple restaurant customer reviews from database. Instead of displaying all reviews individually, these reviews are combined and sent to the Groq large language model. Again, the prompt engineering plays an important role here. The AI is instructed not only to summarize the reviews but also identify the customer sentiments and recurring themes. For example, the demonstration of the AI receives three customer reviews. One customer says the food was amazing, another mentions the delivery was slow, and the third customer appreciates the taste but suggests improving in packaging. Instead of returning these reviews separately, the AI produces a concise summary. It identifies that the customer generally loves the food but are dissatisfied with the delivery performance. The system also performs sentiment analysis by estimating positive and negative feedback percentage. Additionally, it extracts key discussion topics such as taste, delivery, packaging. This allows restaurant to understand overall customer satisfaction and within seconds instead of reading hundreds of thousands of reviews individually. Ultimately, the feature supports faster business decision and improves customer service. Traditional food applications require users to manually apply multiple filters such as vegetarian, price range, cuisine type, or rating. However, people naturally communicate using complete sentences rather than filters. For example, a customer might simply say, I am vegetarian and my budget is 200 rupees. Food Genie allows users to interact exactly like this. The user's request is first sent to the backend. Instead of directly searching the database, the request is forwarded to the Groq LLM. The AI analyzes the sentence and identifies important information such as dietary preferences, maximum budget cuisine, or any other condition. The backend controller then reads the JSON and converts it into the MongoDB query. The MongoDB searches only those dishes matching the user's requirement and returns personalized recommendations. In this example, the application suggests dishes like paneer roll, veg burger, and masala dosa, all within a specified budget. This feature creates much more natural user experience because customer can simply describe what they want instead of navigating multiple filters menu. Now let's take a closer look at the backend architecture that powers the Food Genie. The backend is designed using a modular architecture so that each component has a clear responsibility. Project contains 9 controllers, each responsible for a specific domain such as authentication, restaurants, menus, food items, carts, orders, coupons, and payment and AI services. Separating responsibilities into controllers improves maintainability and makes future features development much easier. For authentication, I have implemented the JWT based authentication along with role based authorization. This ensures that the different users, such as customers and administrators, have access only to the feature relevant to their roles. Since food ordering applications involve many images, the integration of Cloudinary for image storage has been done. Instead of storing images directly onto the server, Cloudinary provides a secure cloud storage along with optimized delivery. The backend also includes an email service using NodeMailer. This allows features such as passwords, reset emails using professionally formatted bug templates. Another important component is the middleware layer. Centralized errors handling ensures that the unexpected errors are processed consistently across the entire application, while asynchronous wrappers simplify the control logic and improves the code reliability. For database management, I've used the MongoDB together with the Mongoose. The product contains multiple schemas representing user, restaurants, menus, items, shopping carts, coupons, and other application entities. Finally, the folder structure has a clean, modular organization separating controllers, routes, middlewares, models, utilities, service, config files. Overall, this backend architecture allows production-ready software engineering practices, making the application scalable, secure, and easy to maintain. After understanding the backend architecture, let's move on to the frontend, which is responsible for everything the user sees and interacts with. Genie is built using React with Vite, allowing me to create the fast, responsive, and component-based user interface. The application follows a layered architecture at the top of the user interface, where users interact with pages like home page, restaurant listing, menu page, cards, orders, login, and admin dashboard. Navigating between these pages is handled by React Router, which provides a smooth client-side routing without reloading the entire application. Each page is made up of reusable React components. These approaches improves maintainability because instead of writing the same code multiple times, components can be reused throughout the project. For state management, I've used the Redux Toolkit. Redux is a centralized store for an application data. Rather than passing the data manually between components, global information such as authentication status, shopping cart items, user profiles, and order details are stored in one place. Whenever the front end needs data from the server, it uses Axios instance. The Axios instance sends the HTTP request to the Express backend and receives a JSON response, which are then displayed to the user. The architecture separates the representation of the state management routing and API communication into the intermediate layer. As a result, the front end remains modular, scalable, and much easier to maintain, and the project grows further ahead. Now, in this section, we will be going through a complete walkthrough of this Genie application. Now, on the left side, you can see all the front end and the back end files. It consists of the controllers, the middlewares, the models, the routes, and in the front end, we have all the CSS, Redux, and the components. So here we have the server.js. So we'll go in the terminal. Here we'll write the command cd frontend. This is changing the directory to the front end. Then we will click on this plus icon and create another PowerShell window. Here we would write the command cd backend. So we have to write npm run dev, this command to start the server. So for backend, the command has been initiated. Now we'll write for the front end. So now we will visit this localhost link. So here you can see all the restaurants that have been added with their reviews, their location, and their review summary. This is the AI graph feature for the review summary. You can just click on any review summary, and here you can see the review has been positive with the hashtags and some of the keynotes. So you can do it for any other restaurant. Here you can see the reviews are some mixed, the dishes are overpriced, but the quality is offered good. So for KFC we can do here the same thing is being shown. So if we see for the login option, so here we can either log in or create a new user. So for new user, let's say we enter the name. Let's say if we enter any email with the password. Here credentials are hidden using the special JavaScript notation. Now if we confirm our password, we enter phone number. We can either choose avatar by browsing, or you can just place our now here we will log in with our ID password which we have registered. So we have a fallback if the login is failed, maybe via the incorrect details. Here you can see our account has been generated. We can log in via the same email and password which we have registered as we have seen, or we can directly click register. So here we can see the restaurants. We can just click any of the restaurants. For example, we click Haldiram. Here we can see all the items that are being provided by the Haldiram. Similarly, we can see for KFC. Here we can see the chicken buckets, KFC popcorns, finger burgers, and we can see for the daily sushi. Let's say we want to add this product. We will increase its quantity to 2. If we want to add some Coke, so these are been added. Let's go to our cart. Here we can see our cart where we can customize by deleting or adding items. If we proceed to the checkout, the Stripe has been integrated. It is integrated as in sandbox mode, but if we want to integrate, we can complete the verification and implement the. So here we can see we have the shipping charges added. So if we enter our full name, then our address, if we enter our mobile number, for our card number, we can enter a dummy card for now. So as you can see, it is been processing. Once it is processed, you can see the order has been successfully placed, and here you can see a toast in which it is written order has been successfully placed. We can just click on go to orders where we can see our recent order. On clicking view, you can see all the information which has been ordered. The order ID and everything information is visible here. If we just go and click any other restaurant, if we want, we can add the item here. We can just select if we want a creamy, just add here batter cup. We can set a price. Now here, for the description, we can either write spicy and click the AI description. Here it would create a description based on the Groq AI model. So here we can see we can write in stock maybe 10. We can add an image URL. Let's do that. For the image URL, we can take or we can click our own image. So I have copied the image name URL. So here you can see a request file option is here because this is an admin related information changes. So only admin can change this information. If we log in as an admin, we can change this information. Now upon logging in as an admin, we can just select the grieving. We can add the menu. Here we have the card interface. Now we have the smart sorting option which shows the pure veg. By sort reviews, we can sort the reviews. By sort the rating, we can sort the highest rated restaurant. By reviews, the highest number of reviews. We can even select the restaurant like here you can see the option as returned KFC. Here if you want, we can change our profile details and change our order. The order status changes from processing to done on the admin side. So this is overall walkthrough of this website. We can deploy this on Vercel or Netlify or render and generate a link that would be accessible over on the internet. The project was developed over a period of 4 weeks, with each week focusing on a different stage of development. During the first week, the planning of the application was designing the user interface, creating the React project, and implementing the authentication system. In the second week, the shift was to focus on the backend by developing React APIs using Express, designing MongoDB schemas, and implementing JWT-based authentication. In the third week, it was dedicated to the AI, the integration of Groq API, designing the prompts for each AI feature, and testing the menu generator, review analyzer, recommendation system, and natural language search. Finally, the fourth week was focusing on the debugging, optimization, optimizing performance, integrating Cloudinary for image uploads, and preparing the project for deployment. This journey taught me much more than just coding. It helped me understand how to plan, architect, test, deliver a production style software application. Building AI-powered software also means solving problems that doesn't exist in traditional web application. The first challenge I encountered was the inconsistent AI response. The LLM can generate different outputs for similar prompts, which creates problems when the application expects structured data. To solve this, the designing of a strict prompt template and implementation of fallback parsing logic was to be done. This ensured that the responses remained consistent and usable. The second challenge was involving the shopping cart synchronization. Initially, different components were updating the cart independently, causing inconsistent information to appear on different pages. The solution was to be centralizing all the cart operations inside Redux Toolkit and using predictable state updates. This ensured that every component displayed the same information. The third was connecting AI output with the MongoDB database. The AI understands human language, but the MongoDB requires a structured query. To bridge this gap, the creation of a translation layer inside the backend controller was to be done. This layer received structured JSON from the AI, validated it, converted it into MongoDB query parameters before executing the database search. These challenges taught me that building production-ready software is not only about writing code, but also about designing reliable systems that handle unpredictable situations gracefully. During this internship, I designed and implemented a complete MERN Stack web application using the artificial intelligence integrated into the core workflow. The backend consists of 9 controllers handling different business operations. The database includes 7 optimized MongoDB schemas. I successfully implemented the 4 AI-powered features, including menu generation, review analyzer, smart recommendation, and natural language search. The application also included the centralization, state management using Redux Toolkit, secure authentication using JWT cloud-based image management through Cloudinary, and a modern REST API architecture. Overall, this project gave me a practical experience in designing full-stack applications while integrating modern AI technologies into real-world business problems. To conclude, Food Genie is much more than a simple food ordering website. It represents everything I learned during my internship, from designing user interfaces and developing scalable backend systems to integrating the artificial intelligence into the practical applications. Through this project, I gained hands-on experience with the complete Monstack Redux Toolkit, JWT Authentication, Cloudinary integration, REST API development, and AI integration using the Groq LLM. Most importantly, this internship strengthened my understanding of the software architecture, debugging, problem solving, and building production style applications. I would like to thank Webstack Academy for providing me with this learning opportunity for guiding me throughout the internship. Thank you all for your time and attention.